Welcome to the screencast of 1.4, solving absolute value equations. And so I believe you've already learned that the absolute value is these two vertical signs. So they're the straight up and down vertical signs. So for instance, if I would take the absolute value of 2, that's actually going to equal the absolute value of -2. Because the absolute value, all it means is it is the distance from 0 on a number line. So since distance is always non-negative, the values are always non-negative. So for instance, my example, -2 is 2 away from 0 and 2 is 2 away from 0. So 2 spaces. 1, 2, 1, 2. They're both 2 spaces. Here, -4 and 4 are both 4 spaces away from 0. So for any real number a, if a is positive or 0, the absolute value of a is a. If it's negative, it'll be the opposite of a. All that means is if it's on the left side of 0, on the negative side of the number line, you take the absolute value, it turns it positive. All right, so just remember that absolute values are always non-negative, aka they're always positive. Let's go ahead and solve. So when you're evaluating absolute value equations, you approach them like you would solve any other one, meaning you follow the order of operations. So you're going to follow PEMDAS. So the absolute value signs aren't exactly on, the absolute value signs are not on PEMDAS, but you can think of them, treat them like they're parentheses. So the absolute value signs will be treated like parentheses. So that means when I look at a, I'm going to have to solve for 4x plus 3 first before I can solve for anything else. Here, x is equal to -2. So I'll just plug that in. 4 times -2 plus 3, absolute value sign, minus 3.5. So I have to evaluate inside the parenthesis, aka the absolute value signs first. So I need to do 4 times -2, so that's -8. And then I'm going to do -8 plus 3, so that's going to be -5, absolute value minus 3.5. And so absolute values always turn everything positive or keep it positive, so then I have 5 minus 3.5 is 1.5. So that's the solution for the first part. The next is, I'm going to rewrite it, so -2, absolute value, 3 minus, remember x is -2. Absolute value plus 8. So the first thing we're going to do is, 3 minus a -2 is the same thing as 3 plus a +2. So inside here will be a +5 plus 8. So as I said, we're going to treat the absolute value signs like they're parentheses, but the parentheses are just magical and they turn anything that's inside of them positive. So here I keep 5 as a positive. And so now, since I'm treating them like parentheses, I'm going to multiply these together to be -10 plus 8 for a total of -2. So I treat them like parentheses because I solve for what's inside first. Okay. And then once I'm done and I have a single value inside, then I treat them super like parentheses. I turn the thing inside positive, but then I'm going to multiply it by whatever the coefficient, whatever's outside. Okay, so using the definition of absolute value. So the absolute value of 3 means the absolute value of x, if it equals 3, it means it's going to be 3 units away from 0. So here's 1, 2 right here. So this value is -3. -3 is 3 spaces away from 0. And then I'm going to have 1, 2, 3, +3. So there's 2 numbers on the number line that are 3 units away from 0, -3 and 3. So this means absolute values always have 2 cases. So absolute values have 2 solutions. You'll have a positive case and a negative case. So I'm going to split this into 2 parts. I'm going to say here's the positive case, here's the negative case. So when you do that, you can actually take away the absolute value signs. So I have x equals, if this is the positive case, I leave the solution as is, so that'd be 3. Now for the negative case, I take whatever's on the right side and I switch the sign. So here, since it was a +3, if I switch the sign, it will be -3. Hence, x equals -3 and x equals 3. What if I have absolute value of x minus 5 equals 3? So that means that 3 units away from 0 is my x minus 5, one of my solutions, and then 3 spaces away from 0 on the other side is another x minus 5 solution, right? Because this is going to have a distance of 3 from the origin. So that means, cool, so I have the positive case and the negative case. So I take away the absolute value signs and I leave whatever was inside. I leave it alone. And then on one of the solutions, I have it be the same number that was on the right side. On the other, I make it be a negative. So you can see x minus 5 equals 3, x minus 5 equals negative 3. When I solve each equation, I see x is going to equal, well, 3 plus 5 is 8. And let's see, x is equal, well, negative 3 plus 5 is 2. So we see 8 and 2. So these aren't equal, like these, the x is not going to equal 3 itself. But when I plug back into the equation, so 8 minus 5, absolute value, that's going to be absolute value 3, that equals 3. Cool. And if I try to check the other side, I have 2 minus 5, absolute value. So it's going to be absolute value negative 3, which is 3 again. Check. So I plugged back in my two solutions and I found this is actually what it's going to equal. So so when you're solving the absolute value equations, how do you find the x? The first step is to get the absolute value by itself, so you isolate it. That means over here, when I have 2 times the absolute value of x minus 2 equals 8, we have to divide both sides by 2 before proceeding. And now I have my absolute value assigned totally by itself. So it says x minus 2 equals 4. That means it's going to be 4 spaces away, 2, 3, 4. And the negative, so it'll be x minus 2 equals negative 4. And let's see, 1, 2, 3, 4. Right here, I'll have x minus 2 equals a positive 4. So those are my two cases, because this is the distance I am away from 0. So I can just go ahead and solve them. So x minus 2 equals negative 4. Add 2 on both sides. I have x equals negative 2. And over here, x minus 2 equals 4. Add 2 on both sides. I have x equals positive 6. So those would be my two solutions. And when I plug in, I would find that, let's see, negative 2 minus 2, because this is the original from up here. Absolute value, so that would be the absolute value of negative 4. That equals 4. Awesome. Plug back in my solution over here, 6 minus 2. Let's see, that's absolute value of 4, so that is equal to 4. Check. Awesome, so we checked our solutions. Let's go ahead and solve these. So consider your solutions in terms of central value and range on a number line. So here, x plus 3 equals 6 just means it's going to be 6 spaces away. So this is x plus 3 equals negative 6. Then over here, 6, we have x plus 3 equals positive 6. So you have two cases. You have the positive case and the negative case. When I say positive, negative, they don't necessarily have to be positive, negative numbers. I just mean I take my right side, I leave it alone, aka multiply by a negative 1, and I will get x plus 3, so that's whatever is in the absolute value, is equal to positive 6. And then the right side is I'm multiplying everything on the right side by a negative 1. So negative 1 times 6 is negative 6. So I'll have what's inside the absolute value, x plus 3, is going to equal negative 6. And then, of course, I'm going to subtract 3 on both sides. So I have x equals 3 as one of my solutions, minus 3 on both sides, and I have x equals negative 9 as my other solution. Over here, so the distance I will be away from 0 is 4. So I have one solution, x minus 7 equals negative 4. Now 1, 2, 3, 4, right here. I have x minus 7 equals a positive 4. So let's see, so it's like I'm going to multiply the right side by positive 1. So it just leaves everything alone. Then over on the right side, it's like I'm going to be multiplying everything by negative 1. It'll be the opposite. So negative 1 times 4 is going to be negative 4. So of course this x minus 7 is what's in the absolute value. And then you have equals negative 4. Alright, so we add 7 on both sides. X is going to equal 11. Add 7 on both sides. We have x is equal to positive 3. So we have two positive solutions. Right, so x is two positive numbers. And this is not an issue because it's only when we plug back in inside the absolute value that we would find a negative 4. So for instance, and just go ahead and do this real quick. So I have 11 minus 7 on this left side. It's going to be absolute value of 4, so that checks out. On the right side, I have 3 minus 7 equals absolute value of 4. Let's see. So that'd be negative 4, absolute value, hey, that equals 4, and I am solid. So it's okay, I have two positive solutions for x, because when I plug it in, the absolute value itself, right, plug it in here, I still get my absolute value is going to equal 4. All right, see? So we have to get the absolute value assigned by itself, so the first step I'm going to do is divide each side by 3. So now my new one I'm trying to solve is absolute value of x plus 5 is equal to 3. So that means I have a x plus 5 equals a negative 3. 1, 2, 3. And I have an x plus 5 equals a positive 3. So I'm just writing shorthand. Instead of writing, multiply by positive 1, multiply by negative 1, I'll just write the plus and negative to make sure I'm taking account that there's 2 solutions for every problem. So in your homework, there will be 2 solutions for every problem. So here, x plus 5 equals 3. Subtract 5 on both sides. X is going to equal a negative 2. And then I have x plus 5 equals a negative 3. So when I subtract 5 on both sides, I find x is equal to a negative 8. Aha, so here, both of my solutions are negative. Not an issue at all. All right, first step empty. I need to multiply each side by 2 because I have to get the absolute value by itself. 4 times 2 is going to equal 8, and these 2's cancel out. All right, so now I'm going to be 8 spaces away. So x minus 3 equals negative 8. And then I have x minus 3 equals a positive 8. Cool. So I'm leaving whatever inside the absolute value sign alone. All right, so that's the positive negative side. So I have x minus 3 equals a positive 8, and then x minus 3 equals a negative 8. Let's go ahead, add 3 on both sides. So I have x equals 11. And I have plus 3 on both sides. X equals a negative 5. Okay, so far so good. Because remember, so the absolute values are always 0 or positive. They're always like their whole number. Absolute values, if you look at the graph, they're always going to have a positive value because literally distances cannot be negative. So if you come up with, if you have a problem, so first, we have to isolate this absolute value by itself. So we have absolute value of 3a is equal to negative 3. So ask yourself, can an absolute value sign, what is going on here? Can an absolute value that will always be positive ever equal a number that's negative? And the answer is no, it can't. Right? So this actually has no solution. No solution. Because an absolute value can never be a negative number. Absolute values are always positive. So here's the assignment. And the last thing I want to talk about is this number 12. So number 12 on the homework says absolute value of a minus 4 is equal to 3a minus 6. So this is what I was talking about, the whole leave the signs. Basically, you're multiplying by a positive 1. So you leave everything alone. A minus 4 equals the original 3a minus 6. And then you're just getting the numbers by themselves. So you subtract a on both sides. So you have negative 4 equals, well, let's see, 3a minus a is 2a minus 6. And then move that 6 to the other side, so add 6 on both sides. And then you come down here, and you'll have 2 equals 2a, divide by 2 on both sides, a equals 1. Now, this right side is the harder side. So this is why I was saying you're multiplying by a negative 1. All right, so if I multiply 3a by negative 1, you get negative 3a. If I multiply negative 6 by negative 1, you get a positive 6. So that's what this is showing, is we have a positive 6. So we flip the sign of everything. So I'm gonna, since this is a big, I'm gonna move this guy over to the other side because it's a negative. And I want my letter, I just like having my coefficient be positive, so I add 3a on both sides. 4a minus 4 equals 6, add 4 on both sides, so you get 4a equals 10, divide by 4, and you get a equals 2.5. Alright, so if you guys have questions, feel free to come to bonus. Awesome, I'll see you later.